All right, so let's start this broadcast with a story that must concern every single one of us. Rapidly melting Antarctic ice is threatening to dramatically slow down the deep water currents in the world's largest oceans. Now, according to scientists, melting ice will have far-reaching consequences. It will impact the spread of fresh water, of oxygen and also life-sustaining nutrients for centuries to come. Our next report gets you more details.
Our world is changing, and it is changing for bad. There is a rumble deep within the oceans, which is sending alarming signals that all is not well within our planet. We all know that polar ice caps are melting due to global warming, but now a new report says that the Antarctic ice is melting at a rapid pace. A team of Australian scientists says that it will cause a dramatic slowdown in deep ocean currents. This could have a disastrous effect on the climate. The new modeling shows that overturning circulation of waters in the deepest reaches of the oceans would slow by 40% by 2050. If the model holds true, the deep ocean current will be on a trajectory that looks headed towards collapse. And this is bad news for our planet's health. Trillions of tons of cold, highly salty and oxygen-rich water sink around Antarctica each year, sending a deep water current northwards to the Indian, Pacific and Atlantic Oceans. The greater volumes of melting ice make the Antarctic waters less dense and salty. However, slowing the deep water circulation with consequences for climate, sea level and marine ecosystems. These deep ocean currents in the northern and southern hemispheres have remained stable thousands of years. But that is changing due to an ever-warming climate. And there's only one way to avert this impending catastrophe. The world urgently needs to drastically reduce emissions to get off the high emission pathway we are currently following.
All right, now to give us more perspective as to why all of this, of course, is happening, we're being joined by Laurie Goring, who is a climate change editor at Context. Ms. Goring, thank you very much indeed for joining us here and beyond. The question that I want to ask you is this. Now, what are the implications of the rapidly melting Antarctic ice?
Well, you can think of this pattern that happens in the Atlantic Ocean as a kind of a conveyor belt that is changing, that is moving levels of carbon absorbed from the atmosphere and levels of nutrients around in the ocean, as well as heat. And that's been operating, bringing warm water up in the tropical areas and then having that sink down in the northern areas near Greenland and the Arctic. And that drives a lot of useful things that stabilize our climate, our rainfall, our agriculture, and so on. But that is weakening as these big glaciers in Greenland and places like that melt, because part of what drives this conveyor belt is the saltiness of the water, and more melting fresh water decreases that. So it could impact quite a lot of things that we're worried about, from food harvest, rainfall, to things like how severe tropical storms are.
Absolutely indeed. Now, a lot of people think of climate change and of melting ice, and they think that the sea levels will go up, a lot of the coastal areas will get submerged, but very few people are aware that this will drastically impact the deep ocean currents as they presently exist. Now, try help us understand as to how a collapse of this gradient, the saline gradient in the oceans, once the ice begins to melt and once the saline gradient also breaks off, how is this likely to impact the flow of water in the deeper part of the ocean?
Well, it'll shut down this circulation or make it go much more slowly and more weakly. And that means that it will affect quite a lot of the systems around that. For instance, the oceans won't, right now they absorb a lot of the carbon dioxide emissions that we create from burning coal, gas, and oil. But it's possible that the oceans won't be able to absorb things at the same level if this circulation slows slows down, which is a big problem because it can accelerate climate change and its impacts. And it's likely, because it affects the evaporation of water off the oceans, it's likely to affect rainfall. Right. And that could change rainfall patterns in a lot of parts of the world, including potentially in India and across South Asia, in western parts of Africa, and also in South America.
Very interesting. Now, you mentioned that this could in fact impact the rainfall pattern in India. The monsoon winds, of course, blow in a certain manner. How will the decreased salinity of oceans actually impact the monsoon rains in India?
Well, it's hard to tell exactly. This change in the ocean circulation pattern has happened in the history, but in tens and tens of thousands of years ago. So we can see some of the patterns of that. We know that it happens, and we know that when it starts happening, it's possible that it will completely change over within decades, which is why people are worried about it. But we don't know precisely how it's going to affect agriculture and what we're doing now, because we've never had this many people living on the planet when it happened.
All right, very interesting there. Thank you very much indeed, Ms. Goring, for joining us and getting us all those insights there.
Thank you.